Okay. Hey, silence. So, there are 100 people surveyed. We ask questions. Do you agree that the women, female soldiers should come back in the battlefield? You know, come back, fight in the battlefield. 100 people were surveyed, and 50 of them are male, and 50 of them are female, and 50 of them are male. Okay? And 32 of the 50 men says yes, they should go to the battlefield and fight against the enemy. And 18 of the 50 male says no, they should not go to the battlefield. Regarding women, 8 of the 50 women surveyed says that yes, women soldiers, female soldiers should go to the battlefield and fight against the enemy. Okay, but 42 of them, most of them says no. Female soldier should not go to the battlefield and fight against the enemy. Okay, so what is the probability, or the conditional probability that given if the man survey is a woman, what is the probability that she will say yes? If you already knew that this person survey is a female, then what is the probability that she will say yes? Women should go to the battlefield. Women soldiers should go to the battlefield. Okay. So if you were given the condition, okay, the person survey is a female, then your sample size, your sample shrink to was confined to 50. Okay, because you already knew that the person survey is a female, so the sample size, the sample space has only 50 items, 50 elements, and the probability that she will say, oh yes, well, female soldiers should go to the battlefield, the number of the event is 8, so it is 50 under 8. Okay, and if so, is a fraction, right? And upper term and lower term, if both upper term and lower term both divided by 100, then the formula becomes no, not this one. I got it. One more. IML. One more. And now, so what is the probability that given that the person surveyed, man or women, the person surveyed says no. You already know that. Right? The person surveyed says no. Oh, female should not go to the bed. Okay. So what is the probability that he or she, he is a man? And it is the number of persons say no. What is it? Number of people say no. Oh, it's 60, right? And he said no, and that he's a man. The man who says no is a man. The one who says no is a man. What is the probability? Oh, man. Oh yeah, it's the one who says no is the man. So it's 80. So 80 over 60. So that's the answer. And this answer will do. Hey, in the exam, if you're answering the fill in the blank question, you can write it this way. Right? 18 in the exam, midterm exam, you will do it online. Fill in the blank, simple. You cannot write it. You can write it 18 over 60 or 9 over 30. All right? 9 over 30. It's okay. I will prepare more than one answer. Okay? And you can also write it. You can also write it. Turn this, convert this into decimal. Okay? Number with decimal places. Or just a fraction. 18 over 60. You will win all the credit. And over 9 over 30, you will also win the total credit. Okay? So what is it? If you divide it by 100, divide it by 100, so it will be probability of the person surveyed says no. And if you divide this by 100, it is the probability that the man surveyed is a man, and also he says no. Okay? Understand? So what is the probability? The probability will be 0.30, or if you write 0.30, you will win the total credit, or you can just write 0.3, or just 0.3. Okay, no problem. Don't worry, you will get the total credit. Okay. Now it's time to introduce the theory of total probability. The theory of total probability. Okay. Theory of total probability. Any event B, I suppose that you have an event B which is a subset. Hello, hello. Yep. Suppose that B is a subset of omega, where omega is a sample space. Okay? And suppose also that, suppose further that omega is divided. We made a division. We separate omega into A and A complement. All right? So if you take an intersection of B and a sample space, okay? Now the sample space is the union of A and A complement, like this, okay? It's mutually exhaustive and mutually exclusive, okay? They join together as a sample space. And also, they have nothing in common. That is, they are mutually exclusive or disjoint. Okay? So, the intersection of B and a sample space is the same as the intersection of B and the union of A and A complement. Right? Hey, remember the distributive law? It is the union of two intersections. Intersection of B and A, and also the union of two intersections. Intersection of B and A, intersection of B and A complement. And the two sets, right? The two intersections, intersection 1, intersection 2, they are mutually exclusive. They are disjoint. Let me I should not use Chinese here because what happened? Eh? What happened to my eh? Oh. Eh? Come on. Go with it. Eh? Oh, here. Yep. They are mutually exclusive. They have nothing in common. It's mutually exclusive. Okay? Disjoint. You can say disjoint. Right? Okay. So now remember the conditional probability we learned last week? Okay? So what is the conditional probability? Probability of A that B may occur. It is the probability of A and B divided by the probability of B. That's what we learned last week, right? Okay. Okay. And now B is the rewrite the set B as the union of the two intersections, intersection 1, intersection 2. Okay? So that's it. And that's because they are this set and this set, they are disjoint. They have nothing in common. So the probability is additive. The probability of B intersection A and the probability of B intersection A complement. Right? Okay. What I will rewrite. Right. Here I will use a trick. I will use the trick. What trick? Divide it by something and multiply the thing you divided. Okay? Okay, divide it by something and then multiply it back. Suppose that you divide it by PA and then you times PA and nothing gets changed. It remains the same. So let me divide it and then multiply. So the upper term, we divide it by the probability of A, and then times the probability of A. So the upper term remains unchanged. So are the lower term, A, divided by PA, and times the probability of A. And here, divided by the probability of A complement, and then times the probability of A complement. So we have another formula. We have another formula here. Hey, so what is this? What is this? This is the conditional probability. This is the conditional probability, which is the same as this. Okay? So we rewrite the upper term as this formula, using this formula. And likewise, hey, for the lower term, it can be rewritten as this one. The probability of B, even that the event A already occurred. Okay, and this can be this term can be expressed as the conditional probability of B, given that the event A complement already occurred. Okay, so that's what we need today. This is what we need today, and that this theory, this identity is called Bayes' formula. Bayes' formula. Let me rewrite. Should I use Chinese? And this is called Bayes' formula. And this is not available in your textbook, I believe. It is not available in your textbook, but it will appear in your midterm. It will appear in your midterm exam. All right? It will appear in your midterm exam. All right? And now, what is the big deal about the Bayes formula? Hey, you don't have this possibility. You don't have this. But we have this. This one and this one. And also this one. Then we can calculate the probability Alternatively, like this, using the other way around. Okay, understand? So then let's go to the famous example here. Yeah. This one. No more Chinese. Bayes formula application. It's going to appear definitely, absolutely in your midterm exam. All right? Yeah, here. Yeah. The word is very, the font is very small, so please use your cell phone to read it. Go to the team on your cell phone and read it. You know, what happened in the previous 3 years? What happened? What is the big event in the world? 2 or 3 years ago? COVID-19. Okay? COVID-19. And what is the test for COVID-19 virus? PCR. Understand? Hence, PCR test can be accurate most of the time, but it sometimes gives false positive result, which is incorrect result, which is an incorrect result. Okay? Sometimes. But the occurrence of false positive is very rare. But it happens. Okay? With very little probability. Okay? So what is the probability that it is accurate? In other words, what is the probability that the test will be positive if the patient is already infected with COVID-19? 97% accurate. So 90%, 97% accurate is the probability that the test result is positive. Given that the man or the woman tested is already infected with COVID-19. When you or he or she or us are infected, then the probability that the PCR test is positive is 97%. Okay? The probability that the test gives correct result. Otherwise, in other words, it is accurate. Okay? And what is the probability that not infected, the man or woman tested is healthy, not infected? Not infected, or you can say, healthy. He or she got healthy lungs. The probability that negative. So it is also accurate. Given that, in the case that the man or woman tested is not infected, in other words, he or she is healthy, or they got healthy lungs, But what is the probability that it's false positive? 4%, inaccurate. Non-effective, healthy, but the result is false positive, which is not good, which is not a desired result, right? So the probability that it is inaccurate when this man or this woman is not effective, okay? So, and here we have a question. The question is on the next page. Okay, so given that someone's test result is positive, hey, positive. And what is the probability that we are calculating the reverse probability, even reverse condition, even the opposite condition. Hey, now we don't have the probability. We don't have it. We don't have the probability. What probability? The probability that when the man or woman tested, the result for the woman or man, the result of the test, PCR test, is positive. Even you were given the condition, right? Someone tell you, the doctor says, oh, the test result is positive. And then you wanted to calculate the probability that you are really infected. Hey, when you were told by the doctor that you are infected, you don't worry. You don't have to accept because the test may be false positive. Okay? The test result is inaccurate. Maybe you are healthy, but let us first calculate the probability that you are really infected, even the condition that your test result is positive. Okay, we don't have the probability. We don't have the probability, but we have the probability. This is what we have. This is what we have. This is what we have. And then we can use this to calculate this. So we can retrieve this probability using this information. Okay? Using this information. Okay, 10-minute break. I will be back. Oh, no, you are too late. What? Hey, please come to me if you are not finished. Hey. What is your name?
祝你生日快乐！祝你生日快乐！Silence.
Test, test. Hello, 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 hello. Oh. Oh, it's here. Hey, 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 hey. And now. So, before we calculate the probability, let us define some event. Hello, 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 hello. Silence, silence, please. Hello, 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 yep. Okay, before we calculate the probability, okay, let us define some event. I is the event that the person is really infected. Okay, and I complement. The person is the event that the person is healthy, not infected. Okay? And what is POS? POS is a short name for positive. The result of the PCR test on the person, on the subject, is positive. Okay, so POS. So, and the desired probability is POS given the condition that the test is positive. And the probability that, what is the probability that the man who is told, men or women who is told positive, okay, the probability that he's really infected. Hey, if you were told by the doctor that you are infected, hey, don't worry, maybe it's a false positive result, okay? You are healthy and positive. Maybe you are really infected and the test is positive. There are two possibilities. Okay, so and we were I have to give you one more condition, one more information. And suppose that 12% of the entire population are infected with COVID-19. 12%. 12% here infected. And here not infected. Okay, and the test result is positive. All right? Positive. Hey, the test result is positive. Hey, the PCR test will also may also give positive result even when the subject, when the person is not infected, or he is really infected and the test result is positive. So this is B. This is B that we previously learned in the last hour. This is B, and this is A, and this is a complement. Here, like this. Yep, here. This is B that we learned last hour, and this is A, and the upper part is a complement. Understand? And so the desired probability is the conditional probability of I, given that the test result is positive. We don't have the probability, upper left. We don't have it, but we have this. We can calculate this. Hey, it is the probability of I intersection POS, the conditional probability. By definition, it is it on the right hand side, by definition. Okay, and hey, you were positive. The result is positive, but it is possible that the man is infected or the man is not infected. Even he or she is either positive or not, even infected or not infected, the test result can be positive. Okay, so two possibilities. Hey, if you are this you belong this category, then you should be happy. Don't worry. But hey, if you are in this situation, then you should be careful. Go to see the doctor, okay? And stay in the hospital. Okay? Yeah. Okay. And divided by pi times multiplied by pi. And divided by pi complement and multiplied by pi complement, and nothing gets changed. And so is the upper term. Likewise for the upper term, here. And what is this? What is this and what is this? It is the probability, the conditional probability given I, and this is the conditional probability given I complement. That's what we have. Hey, this is what we have. This is what we have. And this is what we have. This is what we have. This is what we have. And so is this. Okay? Now everything is ready. Then now we can calculate the probability. If you know how to derive the Bayes formula. Okay? So, hey, 12% of the entire population are infected. So the probability that he or she being tested is infected. It is 12%, 0.12. Okay? 0.12, 0.12, 12%. Okay? Why? Because in statistics, proportion also means probability. Proportion, 88%, also means probability. Okay? So what is the probability that he or she being tested is not infected? The probability is 0.88. Okay? So, and what is the false? This is false positive, false alarm. Okay? 0.04, as I explained previously in the last hour. It's 4% times 0.88 plus this. Accurate, 97%. Okay? 97% times the probability that he or she is really infected. And the upper term, 0.97 times 0.12. Okay. And you calculate the result yourself. You calculate the result yourself, okay? You calculate it. And run it to the fourth. Hey, patience, attention. Your result may be many, so many, maybe 10 or 11 or 15 decimal places. Hey, you have to run it to the fourth decimal places. 45入到小数点以下第4位。Okay, run it to the fourth. When I say this, like this, for example, the probability is 0.79. That this is an example number. 0403 027819, for example. And when I said run it to the fourth decimal places, hey, run it to these decimal places, 1, 2, 3, 4. Run to the fourth decimal places means that you have to answer, you have to give me this answer online. And nothing more. Understand? When you see this, then you have to just give me 4 decimal places. and cut off the later part. But you have to run it. You have to run it into the fourth decimal places. So it's 7, right? It's bigger than 5. Then this term become 3. Understand? And we have to generalize the Bayes formula. Hey, let us take a look at a picture of Thomas Bayes. Hey, that's his photo here. Thomas Bayes. Okay, here. This is Thomas Bayes. Right? And his paper. What is his paper? Let me see his paper. Yep. That was his paper before he died. Only how many page? 2 page. The size of A4, I guess. Okay? What? The formula? Something like this. Something like this. Okay? Maybe 100 or 200 years ago. He's a how to say? He's a reverend. 神职人员呢? Okay? And before he died, he did not publish this paper. No one knows. And even Thomas Bayes himself did not know the importance of his paper. And after he died, I believe he has no family. He had no family because he served in the church, right? He served in the church, no family, and his friend helped to arrange his possession after he died. His friend found this, and know that these 2 pieces of paper are big asset, very valuable idea, and help him to publish after he died. And this is what is developed based on that 2 pieces of paper. Understand? Understand? This is what was developed after he died. Okay, the simplest case. If you wanted to see more complicated case, oh, you have lots of things to learn. But the Bayes formula is originally presented in this form. Okay, in this form. But I don't know why now there is a big school of statistics, big school, a very big camp, 很大的帮派学派哈。Okay, they are develop and extend the idea of Bayes formula. A very big camp. Understand? And let us generalize. Let us generalize. Okay. Let us generalize. Suppose that there are, the sample space is divided into n pieces, cut into n pieces, which are mutually exclusive. Okay, that is, hey, they have nothing in common. Every 2 every two subset have nothing in common. They have nothing in common. So it is mutually exclusive and totally as exhaustive. Let me use this. Yep. Where is it? Where's my pen? Yep, here. Yep, here. That is. This one means, oh no, here. This one means collectively exhaustive. And what is this? This is mutually exclusive. And this is the sample space, okay? Now, suppose that the sample space is divided into A1, A2, A3, all the way to AN. And they are collectively exhaustive and mutually exclusive. Hey, exhaustive means that omega can be expressed as the union of A1, A2, A3, all the way up to AN. And every two of them have nothing in common. They are disjoint. Okay? They are disjoint. And now, hey, in the example of two A1 and A2, hey, in the example of two pieces where the sample space is divided into A and A complement, hey, that's the formula what we learned last hour. But if there are n pieces in the sample space, then hey, we can extend the formula into the sum of n multiplication. First multiplication, second multiplication, and multiplication. If the sample space are divided into n pieces, understand? And that is the general form of Bayes formula. General form of Bayes formula, okay? All right? Okay. Now, hey, now this kind of question is going to appear in the midterm exam. And let me tell you, in the midterm, the question, the omega in question should be divided into only pieces, A and A complement. Just the two, okay? Just the two. All right? Just the two. No more. And you have to answer this kind of question using this formula. This formula. Understand? Yeah, use the formula to answer my question. It's definitely, absolutely to appear in the midterm exam. Okay, so please go to the subsection 4-4 And the title of this subsection is counting rules. And let me start with a simple example. Suppose there are 5 items in a bag. For example, 5 balls, okay? Denoted by A, B, C, D, E, respectively. Suppose further that all items are equally likely to be drawn. Okay? Now Johnny draws 3 of them. Draws any 3 of them, any 3 item combination, 3 of them from the bag. And the drawing is done without replacement. So each number, each item appear just once in a combination. Okay, appear just once because the drawing is done without replacement. Okay. Then there are many 3 item combinations. How many possible 3 item combinations? The number is 10. Namely, let me list all the 10 possible combinations. 3 item combination. Hey, A, B, C. The 3 item can be ABC. The 3 item can be ABD, or ABE, or ACD, or ACE, or ADE. 3 item, okay? Or BCD, or BCE, or BDE, or CDE. Totally 10. Can you give me the 11th combination? If you can give me the 11th, raise your hand and I will give you 100 points for this semester. The 11th. I think it's exhaustive here. Only 10. No 11th, no 12th. Just 10 of them. And we don't care about the order. Oh, you CDE or CED are regarded as the same combination. Hey, when we talk about combination, we are not. It means we don't care about the order of draw. Understand? We don't care about the order. So first C, secondly D, thirdly E is the same as CED, whatever the order. Okay? We just care about the combination, just the 3 item combination. So that's 10. There are 10 such possible combination, and we call it 3 item combination. Okay? Just 10. Okay. Now what's next? We can now permute. What is the meaning of permute? Okay, we can now permute each 3 item combination. The results of all permutation will be next page. Hey, let us look at the permutation. Hey, when we say permutation, we care about the order. Now we care about the order, okay? And the order matters. When we talk about permutation, hey, if that's one of the 10 combination, that's one of the 3 item combination. When we talk about the combination, hey, the 6 possibility are the same thing, just the CDE, just the 3 CDE. This is CDE, so is this, so is this, so is this, so is this, so is this. It's the combination is always CDE for the 6 cases. But when we talk about permutation, permutation means we care about the order, okay? And then we regard them as different permutation, okay? CDE and CED are not the same. Not the same, not the same, not the same, not the same. So each combination has 6 permutations. So each combination each 3-item combination has 6, which is factorial 3 combination permutations. Okay? So totally 60 is the product of 10 and 6. 10 and 6. But what is the 6? 6 is the multiplication result of 3 times 2 times 1. Okay? 3 times 2 times 1. So in mathematics, hey, in mathematics, we call this factorial. 4 factorial. It means 4 times 3 times 2 times 1. Okay? That's 4 factorial. And you can generalize the notation for general numbers, general integer. 5 factorial. And it reads 4 factorial. Okay? It reads 4 factorial. And this is 3 factorial. All right? So we have the formula. And let us go to the next page. Okay? No Chinese character. We don't care about the order. Okay? And yep, here. See that? I think you are not paying attention. Hi. Are you finished? You are not paying attention. If you fail this course, then you have to attend other teachers' class sometimes in the future. Maybe I don't think the next teacher will be as warm-hearted as mine, okay, as me. Maybe more difficult to pass. Understand? Don't miss the chance. Or you will be sorry. So let us rewrite the formula. 10, okay, is equal to 60 divided by 6. What is 60? 60 is the number of permutations of a 3-item from 5. So number of 3-item permutations from 5 items. So 5 permute 3. So we read it 5 permute 3. It means that we choose 3 items from 5 items, okay? And the 3 items you choose, you permute. You calculate all possible permutation. You rank them in different ways. So P5 3 is the number of 3 item permutations from 5 items. And what is 3? 3 is the number of permutation of all of a 3 item combination. Okay, like this. 3 factorial is 6. This is 3 factorial is 6. Why 6? Because each combination has 3 permutations. When you see permutation, you have to think about the order, okay? And the order matters, okay? And P10 is the number of 3 item combination from 5, and C5 3 read 5 choose 3, okay? So 5 choose 3 is equal to 5 permute 3 divided by 3 factorial. Understand? That's the basic formula from 5 item example, 5 item drawing example, okay? And no Chinese. Yep. Here. And I wanted to generalize from this example. This is the basic formula to generalize for general number of items, general number of drawings. Okay. So C53 is equal to 5 permute 3 divided by 3 factorial. Okay. Now to generalize, when 5 becomes n and 3 becomes k, all right? So this is p and k divided by k factorial. And now, hey, 3, here 3 is the result of 5 minus 3 plus 1, okay? So p and k is equal to n times n minus 1, n minus 2, all the way down to n minus k plus 1, like 5 minus 3 plus 1, okay? So I wanted to use another trick this time. Hey, let us multiply the upper term by n minus k factorial. Multiply by n minus k factorial on the lower term for both terms, and nothing gets changed. But what is this? The upper term when it is multiplied by n minus k factorial. It is n factorial for short. Exactly the n factorial. And what is this? This is k factorial, and this is n minus k factorial. All right? That's the formula. And this is going to appear in your midterm exam. All right. And let us take a look at a very simple example here. Let us go back to the poker. How many cards are there in a deck of pokers? 52. Okay, 52. 4 times 13 is 52. All right? Understand? There are 4 kinds: clover, heart, diamond, and spade. All right? Hey, the idiom, call spade a spade. What is the name? What is the name of Taiwan? And your answer, you can say, oh, we can call Taiwan, call spade a spade. Okay? And usually we often draw 5 cards for one on the upper left, a spade, the first eight. And a 7 clover is this one. Okay? Diamond Q is this one. This one. And spade Q is here, the first one. And then diamond 3. Diamond 3 is here. This one. That's a 5 card combination. And we call this one pair. One pair. You got a one pair. Hey, is the combination strong enough to win your opponent? Is the 5 card combination strong enough to beat your opponent? No, I don't think so. Why? Because it is very easy to get this kind of combination, and this kind of combination is called a spade. It's called one pair. What about 2 pair? This is 2 pair. This is 2 pair. Hey, Q 10 10 3. Right here, Q 10 10 3 is 2 pair. And a 3 of a kind. 3 of a kind. Q 2 3 is it's an example of 3 of a kind. And what is straight? Straight means, hey, straight means 3 4 5 6 3. This is straight, okay? This is a straight, regular straight, not a valuable straight. And what is a full house? Full house means 3 of a kind plus 1 pair. That's a full house. Okay? What is flush? Flush means, hey, this is a flush. This is a flush. Flush means, hey, if you got any five card combination from the 13, or from the 13 cards, then you get a flush. Okay? And what is straight flush? Straight flush in Chinese is called 同花顺. Okay? Straight flush. What is straight flush? Hey, this is a straight flush. Okay? But this is a very, very strong. That's a royal. I know it's a royal flush, but it is also probability using the formula we just learned. Okay. So let us look at the first probability, one pair probability. There is no E here. There is no E here. No E here. Yep. One pair. Hey, what is one pair? One pair is a combination like this. QQ, QQ. Okay, but this is one pair combination QQ. Oh, why am I not taller? Right here. Hey, this is one pair combination QQ, and so is this one pair combination QQ. One pair combination QQ. One pair combination QQ, right? So how many possible one pair combinations with QQ? 6. Or you can say 4 choose 2. The number is okay. So you can make it one pair with QQ, or you can make it one pair with AA, right? Or you can make it one pair with 777. Understand? So how many possible numbers can we choose to make a one pair? We can first choose one from 13 numbers. So it is 13 choose one. Understand? And when you determine, it is QQ. So how many QQ combinations are there in the one pair? QQ combination. 4 choose 2, right? Understand? So it is 13 choose 1 times 4 choose 2. Understand? Okay. So we are already solved. We already solved the 1-2Q combination, or AA combination, or 7-7 combination. Hey, when you got QQ combination here, the 3 card, any one of the 3 cards cannot be Q anymore. Okay? It must be different from Q. So there is no way to choose a card from the 4 card. Understand? So how many numbers can we get from 12 numbers? Now 12. It is no more Q. So the number you can choose is 1, 2, 3, 4, all the way to 8. It is 12. So it is 12. Choose 3. Choose 3. 1, 2, 3. 12. Choose 3. 1, 2, 3. So it is 12. Choose 3. So it is 12. Choose 3. Okay. And suppose that the 3 card combination is not determined. Suppose that the 3 combination is not determined. Hey, it is 8, 7, and 3 to make a 1 pair. Understand? So how many 8 can you use with the 8? How many choices can you make with the number 8? The 8 can be any one of them. 4 of one of them. Any one of them. Okay? 7 can be any one of the 4. And 3 can be any one of the 4. So the probability on the upper term, hey, 4 choose 1, 4 choose 1, 4 choose 1, 3 times. Okay? And this is the common denominator. This is the number of 5-card combination. You draw from 52 cards in a poker, from a deck of poker. Understand? So this is the first probability. Hey, local time, don't panic. And I'm going to make an announcement. Announcement for our midterm exam time. 15 this time. Wednesday, what time? 7 p.m. You got a second chance to take the exam? No, non-negotiable. Understand? So keep safe, keep healthy, and keep availability. Understand? Don't worry, no second chance. Because it's taken online. And hey, local time. Where is my mobile phone? Hey, what happened? Where's my mobile phone? Hey? Hey? Where's my mobile phone? What happened? Hey! What happened to my mobile phone? Where is it? Hey?
好吧。